Some of the world's most dramatic landforms are shaped by the movements of the Earth's surface. The surface of the Earth is divided into about 20 huge plates of solid rock. These plates are constantly moving in slow motion. Where one plate meets another, there can be violent activity, mountain building, volcanoes, and earthquakes.
A state of emergency has been declared in Los Angeles after the city was rocked by a severe earthquake. At least 21 people have been killed and hundreds injured. Houses have slipped off their foundations and sections of 2 major motorways have buckled. Electricity, gas and water supplies have been cut and rescue teams are tackling dozens of fires.
The biggest earthquake in Britain this century shook many areas just before 8 this morning. The tremors were picked up by seismic sensors.
In Warrington, 2 steeplejacks were caught 150 feet up a church tower.
Oh, all of a sudden the tower and scaffolding started to shake and that sway about. And there was a crack in the top of the wall which has opened up to about 10 feet in length. And we just got down from there as quick as possible.
An earth tremor measuring more than 5 on the Richter scale shook much of England and Wales this afternoon, causing minor structural damage to some buildings. The tremor, centred on Wrexham, struck just before 3 o'clock. It was felt at places as far apart as Carlisle, Bristol and London.
The earthquake that hit a remote part of Western India early this morning killed at least 6,000 people and injured many more, according to government officials. The final figure, it said, could be much higher. Military relief and rescue teams fanning out across the region found what they called a human tragedy of unimaginable proportions.
In Sicily, plans are being made to use explosives to redirect the lava flow from Mount Etna. Now the flow of lava is threatening 2 towns on the slopes of the mountain.
Powerful explosions have rocked the Philippine volcano, Mount Pinatubo. Another huge mushroom cloud of debris rose into the sky as the volcano spouted molten rock and boiling mud. Lumps of pumice the size of ping-pong balls fell up to 25 miles away. Because of the early warnings, only 2 people have been killed, but at least 40,000 people have fled the area, many of them now in crowded evacuation centers.
Plate tectonics is the theory that explains volcanic activity and earthquakes. Nearly all this activity happens at the edges of the plates, the so-called ring of fire around the edge of the huge Pacific plate, and the mid-Atlantic ridge, where 2 plates meet under the sea. Most volcanic activity happens deep beneath the sea. On land, the surface of the Earth can be thrust up or ripped apart. As plates move apart under the sea, new rock is formed from the molten rock below. Places where this is happening are called constructive margins. Where plates are colliding, one plate subsides and slides beneath the other. This is called a destructive margin. The massive amount of energy involved in these great plate movements can cause earthquakes. Molten magma can rise to the surface through volcanoes. Most volcanoes on land are at destructive margins, caused by friction where rock plates grate against each other. Melted rock, called magma, rises to the surface as lava. Ash and gases also erupt into the air. The ash can travel thousands of kilometers and affect the weather in countries far away. Layers of lava and ash can solidify to build the slopes of the volcano. However, most lava erupts through huge cracks called fissures. Iceland lies on a constructive margin. The island was almost completely formed of lava that has risen above the surface of the sea. There are 27 active volcanoes in Iceland. The local inhabitants have become accustomed to living with volcanoes. The land is riven with fissures where lava has forced its way to the surface. The heat in the ground is harnessed as geothermal energy. More than 85% of Icelandic homes are heated this way. Groundwater is heated and escapes through vents as steam. Farmland is made fertile as lava adds minerals to the soil. Mount Etna on the island of Sicily is an example of a volcano on a destructive margin. Etna is still an active volcano, attracting thousands of tourists every year. Local people live near the volcano because the land around Etna is rich with potash and phosphates from the volcanic lava. Other parts of Sicily are not so fertile. After the eruption in 1992, rivers of lava flowed down the slopes. And threatened the buildings below. "7,000 people live in the town of Zefirana, just below Mount Etna. To protect the town, the army was called in to stem the flow. They tried to blast the lava onto a different course with explosives. Once it's solidified, lava can be built up into barriers. Even so, houses can be lost overnight and lives totally disrupted. This man said, "You never know what the mountain's going to do. It plays ugly tricks. Only Jesus Christ knows what will happen." It is possible to predict volcanic eruptions. Volcanologists are scientists who monitor volcanic activity. They measure the volcanoes, watching for bulges in the surface that may give a warning that magma is building up and the volcano is about to erupt. Seismographs record tremors, seismic activity at the Earth's surface. When the tremors are this strong, people may have less than an hour to get clear of the volcano. Earthquakes may happen for just a few seconds, but the devastation is long-lasting. Where plates meet and move in different directions, a tremendous amount of pressure builds up over time. This pressure is released suddenly. The Earth moves along a line of weakness called a fault line. This sudden movement causes the Earth to quake. The fault can slip more than 10 meters horizontally, and the movement may be both horizontal and vertical. The amount of movement shows how much pressure has built up. In California, there's a plate margin where the North American plate is slipping alongside the Pacific plate. There are several fault lines here. A major one is the San Andreas Fault. This is the San Andreas Fault at Palmdale, California. This has been an important site for scientists to find clues about earthquakes. They've cut a vertical section down into the peat here. The peat was laid down in layers over time. The layers show a major slip caused by an earthquake has occurred roughly every 150 years. In 1906, San Francisco had a major quake, which killed more than 2,500 people. Although the San Andreas Fault is a known hazard, San Francisco has continued to grow as a busy city. In October 1989, an earthquake shook San Francisco for 15 seconds. Security cameras and home videos captured the event.
Oh my God, we're having an earthquake. Wait a minute. Hold on, hold on. Can you feel that?
I sure can.
Okay, this is interesting. There go the lights. Oh. Oh my God, what an earthquake. 911 emergency.
Yes, have you gotten word about the Bay Bridge?
What about the Bay Bridge? What's wrong with it?
The upper deck appears to have collapsed during an earthquake.
Hold on a second. Jesus Christ, we gotta report that they might have on the scene.
We're over the Bay Bridge now, once again. A section of the upper deck has collapsed.
So I need an ambulance. Hold on, I'll transfer.
Prepare yourselves! Shut off the gas, shut off electricity, store water in your bathtub. Don't expect services for 72 hours.
A lot of damage was done by fires caused by gas leaks and by the collapse of the double-decker freeway. The upper story collapsed onto the cars below. and this is where most of the 67 fatalities in the quake happened. In fact, the buildings in San Francisco were strong enough to withstand the quake. The result of such strong movements of the plates in California could be very dramatic in the long term. This is one projection of what could happen as the plates move over the next 60 million years. In 1993, an earthquake shook Latur, a village in central India. The quake was totally unexpected. 10,000 people were killed in this densely populated area. It was the middle of the night, and they were trapped in unstable houses made from stones and mud. 20 villages were totally destroyed. Latur is isolated, and it was difficult for rescuers to reach the survivors. The quake was unexpected because Latur is in the center of India, far away from plate margins. The theory of plate tectonics still needs refining. Volcanic and earthquake activity should be very unlikely in the middle of plates. It may be that in some areas the plates are crisscrossed by a web of minor fault lines. A movement at one of these could have caused the Latur quake. Another theory is that reservoirs containing billions of tons of water could exert enough pressure to trigger earthquakes. There is a reservoir very close to Latur, and a third of India's recent earthquakes may have been triggered by reservoirs. It's impossible to predict when or where an earthquake will take place. Earthquakes occur whenever there's a release of tension between the plates. But planning and preparation for earthquakes in high-risk areas can save lives. Many people are killed by collapsing buildings. Designs can be tested and improved with an earthquake simulator. Horizontal crossbeams can be built into walls to spread the effect of the shake. These can be made with local materials. And vertically, flexible girders can absorb the tremors. There are nearly 10,000 kilometers of British coastline, shaped and reshaped by wind, rivers, rain, and the dynamic forces of the sea.
Now to a cliffhanger in Scarborough, where tonight one of the town's top hotels is in danger of collapsing over a cliff and into the sea. Guests were evacuated from the Holbeck Hall Hotel this morning after the gardens disappeared in a landslide. Since then, the conservatory is gone, and experts say there's nothing they can do to save the building. The people of Tywyn in Clwyd fear their homes could be flooded again this week when the worst of the spring tides are expected to hit the North Wales coast. After the storms that devastated the town last month, there's concern that the newly repaired sea defences could be overwhelmed again.
As waves crash against the coast, rock fragments are flung at the cliffs. This is called corrosive action. The breaking waves also have what's called a hydraulic effect. They force air into cracks. This is like an explosive charge blasting the rock apart. By cutting into the rock, waves form caves, sometimes cutting through from both sides to form arches. When the ceiling of an arch collapses, stacks are left, standing like pillars, where the cliff used to be. Headlands are more exposed to the waves than bays, and so they are more severely eroded. Cliffs made of rock like chalk and granite are resistant, but softer rocks, such as boulder clay, crumble and slump easily. The distance of open water over which the waves have been built up by the wind is called the fetch. The greater the fetch, the more powerful the waves. Beaches are the best natural defenses for cliffs. They absorb the destructive energy of the waves. Where waves come in and go out at an angle to the beach, they can carry sand and particles down the shore in their backwash. Gradually, material will be transported along a beach. This is called longshore drift. The Holderness Coast in the northeast of England is largely made up of boulder clay, which crumbles easily. The cliff edge moves ever closer to buildings which were once safely inland. The village of Mappleton has lost houses, holiday chalets, and roads. The land in the distance was part of the village 60 years ago. Mappleton's residents are well aware of past and future losses.
My house was well over a quarter of a mile away from the sea. I can remember a field being there. And there was the parade ground that when it was the army camp. And there was the gardens. They've all gone now.
If we don't make a stand and get something done now, it isn't just Mappleton that's going to go over. All the villages further inland over years to come.
In 50 years' time, this slice of the Holderness coast could be lost. Land is eroded here faster than anywhere else in Europe. Many other villages have already been washed away. Further south on the east coast, the medieval town of Dunwich in Suffolk has already disappeared into the sea. The material swept away by the sea is also returned to land, deposited on shore further south. One classic landform created by deposition is Spurn Head at the mouth of the Humber estuary. In medieval times, This headland used to be washed away and reformed every 200 years. Since then, it's stabilized its shape. Around the wash and the broad curve of Norfolk, the material settles as mudflats, and it also settles as sand dunes. The salt marshes which grow up on the deposits in Norfolk are extremely effective barriers against the sea. They are often reclaimed for cultivation. Some sediment has been traced to Belgium, Denmark, and the Netherlands. Once, for every hectare of land lost through erosion, 8 hectares were deposited elsewhere. Now, engineers work to control the coast. To prevent the loss of land and buildings, the coast can be protected. A beach can be retained by wood or stone groins. The beach then acts as a buffer against erosion. The groins reduce longshore drift. The beach is built up on one side of the groin, but material is swept away from the other side, and this can mean that beaches further downshore are not built up. Cliffs are exposed and undercut by the waves. Crops can be lost overnight. The problem of coastal erosion has been shifted but not solved. Beaches can be built to protect the coast. At Heacham in Norfolk, engineers have brought in material to strengthen the sea defences and create a new beach. Ecologists favour encouraging grasses that hold sand dunes together to form barriers against the waves. The extreme solution to protect the British coast would be to build a concrete wall round all 10,000 kilometres of the country. How should decisions be made about which land to protect and which land to let go? What does it cost to fight the forces reshaping Britain?
If we look at the 1,000 metres that we're talking about here, that's a £6 million scheme. The local authority then would have to finance the whole scheme. They just cannot afford it. Whether it's this local authority or other local authorities, that sort of financing from one scheme couldn't be justified currently or perhaps in the future.
I can't see why the cost effectiveness should come into this at all. And during the war, we fought to save the country. Now the North Sea is taking it away.
The land here is not worth a great deal. It's agricultural land. Where the mud is going is to protect the mudflats in front of some very important towns such as Amsterdam, London, King's Lynn, and an enormous amount of money is at stake. What is most important to us is what we ought to be asking. Should we be protecting agricultural land here by stopping the erosion, or allowing that erosion to take place and protect some of the biggest cities in Northern Europe?
The only safe defence against the sea is a good beach, and that you will never have good beaches if you try and defend all the coast. So you've got to allow cliffs like this to erode and to feed the sand into the beach. And this coast has been going back at about half a metre a year for 6,000 years, and I think it's pretty arrogant of us to try and stop it now.
This isn't just land that is going. There's an awful lot of the agricultural land is going, but this is England that's going.
Rivers are usually a pleasure. We use them to relax and unwind. They're also vital in providing water for our homes and industries. But they can be dangerous. Rivers sometimes flood, especially after heavy rain. The natural overflow for a swollen river is onto its floodplain. In recent decades, more and more houses have been built on floodplains. Now, flooding is a problem.
It was overnight that it changed really from just being a pond in the garden to being really the river coming up to the back door. We moved here to get nearer to the river, not for the river to get nearer to us.
How have rivers formed their floodplain in the first place? The source of a river may be at high altitude, like the River Rhône, which starts as melting drops from the Rhône glacier in the French Alps. The most common source of rivers is rainwater. The River Severn emerges from waterlogged ground in Wales. The stream soon builds up a body of water strong enough to erode a river channel. It may cut into the rock to form waterfalls. The impact of the river falling scoops out a plunge pool. Many waterfalls form where a layer of harder rock cuts across the river. It can't erode this rock, and so there's an abrupt break. At high force, the tougher band of rock, called whinstone, lies on top of weaker slates. Gradually, the slates are eroded, and so the whinstone on top collapses. Over a long period of time, the river erodes further back to form a gorge. The material eroded by the river is also transported downstream by the water. Boulders are rolled downstream as the bedload of the river. You can see the load through the glass sides of this artificial river, called a flume chamber. Smaller stones or pebbles are carried in the flow and sometimes strike the river bed. This forces other pebbles into the flow. This bouncing motion is called saltation. The finest particles can be carried in suspension. The Yellow River in China carries so much mud in 1 year that it would bury the city of London a metre deep. As the river flows slowly, only the smallest particles are moved. As the flow increases, bigger pebbles can be carried, but only during floods are the very largest boulders moved. As the flow decreases, the larger pebbles are deposited first because they take most energy to carry. The stones and particles are deposited to form bars and banks. The river bends and curves more around these banks. On the outside of the bends, the water moves faster and erodes more. On the inside of the bends, the water moves more slowly and deposits more. The bends in rivers are called meanders. The river can sometimes meander back so far that it short-circuits itself. It cuts off a section of its own course. When this happens, it makes a curved lake. This is called an oxbow lake or ing. Often these dry out, and their distinctive shape can be spotted from the air. Over a period of many years, the river may have meandered and changed course several times, flattening the surrounding land. This wide area, called the floodplain, is where the river would normally overflow after heavy rainfall. When the river floods, it spreads out sediment over the floodplain. As the river reaches the sea, it deposits most of the remaining sediment it's carried. These particles of clay, silt and sand flatten out into a muddy estuary at the river mouth. Here, the river meets the sea at Barmouth in Wales. At its mouth, the river can split and change course many times. Such an area is a blend of land and sea. In France, the river Rhône forms a shape called a delta because it's shaped like the Greek letter delta. This is a triangular area of land reworked many times by the river. Rivers do not always flow serenely along fixed courses within their banks. They carry enormous volumes of water, and after heavy rainfall, the river channels can't always contain the volume.
And in Germany, the Rhine burst its banks, flooding the centres of Bonn and Cologne.
Swollen by days of continuous rain, the Rhine breached its banks, raising the river 35 feet, its highest level in 67 years, and submerging the ancient heart of Cologne. Thousands of people have been evacuated, and among several deaths, a youth was electrocuted when he rode a motorbike across a power cable. Many people have been moved into emergency accommodation. Electricity and heating have been cut off, major rail routes are disrupted, and shipping has been halted on the Rhine, normally Europe's busiest waterway.
In Bangladesh, at least 75 people have died in floods following a series of storms. The capital, Dhaka, is almost completely surrounded by floodwater, and many towns in the east and southeast of the country have been badly affected. 60,000 people have already been forced to leave their homes, and the rains are expected to continue at least until the weekend.
The gales and heavy rain of the past few days are still bringing flooding and widespread damage to property in many parts of the country. There's still severe flooding in the Severn Valley, and the water level is rising in and around Gloucester, where they're experiencing the worst floods for 40 years.
The Severn Trent Water Authority says it's the worst flooding since 1947. The River Valley was overwhelmed as water rose nearly 2 feet in 24 hours. Dozens of homes were underwater, countless roads blocked. Between Bewdley and Worcester, thousands of acres of farmland were submerged. In Worcester itself, the cricket ground and racecourse have become lakes.
More and more houses are built on river banks, so it's become very important to prevent flooding. Dams are the most effective method of controlling rivers. The water flowing into the river is regulated by holding water back in reservoirs, like this one at Cow Green on the River Tees. There's a plan to cut an extra channel to allow the River Thames to carry more water. This would reduce the risk of flooding. Dredging has been used to deepen the channel of the River Blackwater in Northern Ireland. The deeper channel can carry a greater volume of water. Often trees have to be cut down to allow access for dragline dredging. This can damage the banks in the process. Vegetation holds banks in place. If this is removed, the banks weaken and slump into the river. This narrows the channel and restricts the flow of water again. Another solution is being used in Norfolk. The River Ouse usually floods thousands of hectares, but now it's being lined with branches from hazel trees. They're used to make mattresses to line the river channel. The mattresses are weighed down by boulders. They merge into the bed and bank and make them more stable. Banks can even be reinforced with concrete, but then the river can end up looking more like a canal. Compare the old flow of the Rhone on the right with the controlled flow on the left. The Mississippi is one of the most heavily controlled rivers in the world, but in 1993 the Mississippi burst its specially engineered banks. Even the strongest reinforcement may not contain a river. Several communities were wiped out by the floods. Did engineering help cause the floods?
The evidence is indisputable. The great 1993 flood on the Mississippi River was a man-made flood. Man caused this flood by river engineering, and there's no dispute about it.
It was a flood created by large rainfall. Rain causes flood. It's that simple. Rain causes floods.
The Mississippi stretches for more than 2,000 miles through the middle of the United States. It drains half the country and carries a huge volume of water. In its natural state, the Mississippi would meander and flood each spring, spreading out into the surrounding wetlands and swamps. After heavy rains, the river used to spread out into the entire valley. Over millions of years, it's flattened a wide floodplain. The river used to change course constantly, forming and reforming sandbars. This caused problems for ships trying to navigate the river to take cotton and crops down to the sea. The US Army Corps was called in to control the river. They devised a way to make a deeper, navigable channel. They built stone wing dikes out into the river. Sediment collected, forming new banks. This narrowed the channel and forced the river to dig down. The Corps built thousands of dikes along the whole length of the river. This stabilized the bank. They lined the river with mattresses of concrete slabs. The engineers also built dams to control the water flowing in from smaller rivers. Because of all the settlements on the floodplain, even small annual floods had to be stopped. They also tried to wall in the river. These walls, called levees, were built along the whole length of the Mississippi to protect the farms, homesteads, and factories on the floodplain. But in the summer of 1993, the rain was so heavy that the levees broke. Houses were flooded and the crops were lost. The water level had built up high inside the levees. When they broke, the floods were more violent and sudden than they would have been naturally. The levees were not built high enough to withstand extreme water levels. How much should be spent preparing for the most severe floods?
The fact that levees were overtopped in this flood doesn't mean that river engineering doesn't work. That system was designed for a certain level of flooding, let's say once in a 100-year event. But when a larger flood comes along, society chose not to pay for this larger level of protection.
We chose that elevation because of economics. We can build levees higher, but they were not built for this flood elevation. That doesn't mean that the levees failed. That doesn't mean that the levees didn't work. They did what they were supposed to do, but they were not designed for a water elevation, a huge flood, a Noah's flood that we just experienced. That's not what they were for.
If I had my way, we would be restoring floodplains to their original function, their natural function. We would be restoring the wetlands, restoring the riparian forests, and we would not have suburban tract housing across the floodplains.
In the past, wetlands were considered fetid swamps, areas of pestilence, and society felt that the best thing that could be done with swamps was to drain them and put them into productive agricultural use. If society believes that wetlands are important now, then society ought to make that decision and make those trade-offs and restore the agricultural lands that are in the floodplains to wetlands.
What we ought to be doing is really dynamiting and blasting out and getting rid of a lot of these river control structures. We really don't need them. We've got to let rivers get back to their natural functions. We've got to stop engineering them. So I say, get these wing dikes out of the river, get rid of the levees, and start turning this river and rivers around the world back to their natural condition. Live with floods, learn how to live with them. Get off of the floodplain if you can't live with them. This is the message.
We've all cried until there was no tears to cry anymore. And we've just all come to the conclusion that we've got to just go on the best way we can. But as far as the future, I have no idea what I'm going to do. I live on a fixed income. I lost my home, which was paid for, almost all my belongings. I have no idea what's going to happen from here on.
I got a chance to go back and rebuild on my house, but my wife asked me,
and I promised her that the flood would never come again. And I couldn't answer that. So she didn't want to go back, but I would.
We're beyond the point where you can continue to build levees higher and restrict the flow of the water, because you're not going to slow down Mother Nature. You know, we saw that this summer. The force of the water is not going to be tamed.